Okay, so I'm going to go over the graphs of the derivative notes with you, and so we'll start on this first page. There's two examples here, but we'll start with that first one. The AP test usually gives you a little bit better of a paragraph here, and they don't put this information floating around up there, but it's there for me. These questions are usually a little bit harder for students to get because you're trying to connect a picture you're seeing to another concept, and the picture seems like it contradicts the other concepts. But what you have to get in your head is this picture is the graph of f prime. That's the only information you have about f at all, is you have a picture of its derivative, and you have to turn its derivative into the original function, into the second derivative. And the AP test loves this because the derivative sits in between the original function and the second derivative. And so to go from the original function, or from the derivative to the original function, you're going to have to take an antiderivative. And to go from the derivative to the second derivative, you're going to have to take a derivative. So they get both parts of calculus into the same problem. So whenever I do these problems, before I start reading the questions, I try to look at this picture and try to interpret how does this graph relate to f of x and to f double prime of x. So I'm just going to make some notes to myself. Okay, so f prime of x is the picture. And so if I want a value of f prime of x, I'm going to look at the y value on the picture because f prime of x is on the y-axis of the picture. So that's all I'm going to do. If they ask me anything about f prime, I'm looking at the picture. Okay? But if they ask me about f of x, how do I use the information given to find something about f of x? Well, f of x is going to be the integral of f prime of x, the antiderivative of f prime of x. Well, how that relates to the picture, any kind of integral on a picture, we're doing f prime of x times dx here, and we're adding them up. This is the area, but we must have a start and end. If we're going to do an area, you have to be given an interval. So we must have an interval. And so that's something that we may have to add in ourselves. But if they ask us anything about f of x, it has to be the area. And then if they ask us about f double prime of x, well, we know that that is the derivative of f prime of x. To go from f prime to f double prime, we would have to take a derivative. Okay, but how do we take a derivative on a picture? And this is where you have to understand that this is going to be the slope of f prime, because the derivative is the slope, and so since we're given a picture, we're going to do the slope of f prime. That's how we're going to do the second derivative here. But the other thing that I would add in is I would do my little sign lines, the sign lines we've been doing all year long for this particular picture before I even read the questions. But having this understanding of these three things, the relationships, is really a key. And if you can get that understanding down, these questions become pretty easy. If you don't have that understanding, they're going to be very difficult. So if I were going to do a sign line, and I'm still ignoring the questions underneath this, but if I were doing my f prime of x line, every time we've done one of these, we go find some numbers to put on this line, and whenever we put these numbers on, we set f prime of x equal to 0. That's what we do. Well, if we had a function, we would go solve that. We would factor and solve. If we had a calculator, we would do the same thing. But since we have a picture, we're going to look at where f prime of x is 0. And as we talked about earlier, f prime of x is just going to be the y value on the picture. So if you're looking at the picture, I see that f prime of x equals 0 right here and right here. Those are my only 2 points. So I'm going to put 0 and 3 on my line. And then we have had to fill out the intervals in between 0 and 3, to the left of 0 and to the right of 3. And so if we go through this, we would look to the left of 0. What is the sign of f prime of x? Well, f prime of x is, again, the y value on the picture. And those y values are positive right up there. Okay, and then in between 0 and 3, all of these y values are, again, positive. And then to the right of 3, all these y values are negative. And so if we do what we've done all year long, we do these little up lines and down lines, what that will do is give you a picture of the original function. That's what it looks like. Okay, and so just to connect some things we've been doing, we would say on this little sign line that there's a max at x equals 3 because f prime of x changes from positive to negative. Well, if you look at the picture, you should see that agree, that f prime of x, which is the picture, is changing from positive to negative at x equals 3. And nowhere else does f prime of x change signs. So whenever we've written justifications for max and mins, it was never that f prime of x was 0. That was just to get us a division of our interval. It was that f prime of x changed signs one way or the other. So there's our little sign line. Okay, and then if we did the second derivative sign line, what we always did for the second derivative sign line was we took the second derivative and we set it equal to 0. This one's a little bit harder to understand. But if we go back to our kind of definitions of where we would get things, f double prime of x is the slope of this picture. Okay, and so if we want to set the second derivative equal to 0, we need to set the slope equal to 0. So if we go back and look at this picture, we're looking for where we could draw a slope of a tangent line equal to 0. Well, I can do that at 0, and I can do that again at 2. And nowhere else can I draw a tangent line that has a slope of 0, a horizontal tangent line. So that's what I'm going to put on this sign line, is 0 and 2. And again, we have 3 intervals to fill out. We have left of 0, in between 0 and 2, and then right of 2. And this time we're looking at the slope of f prime of x. That's how the second derivative relates to this picture. So the slope to the left of 0, these slopes are negative. All the way along, those slopes are negative. In between 0 and 2, those slopes are positive. And then to the right of 2, those slopes are negative all the way down. They're different slopes, but all those slopes are negative. And so we would draw in our concave down and our concave up symbols. Okay? These two lines give you a good picture of what the original function looks like. However, they look nothing like this original picture, and they're not supposed to. This picture is of the derivative, which can look nothing like the original function. And so these are what's going to help us know something about f itself. Okay, and so now if we have all that information down, these questions should be fairly simple. So A says, can you find any inflection points of f of x? And every time we've done inflection points, we've taken the second derivative, and we've set it equal to 0, and then we checked our little sign line. And so since we've already done this sign line, we can see that there's an inflection point at 0 and 2. And to justify all this time, we've always said, because f double prime changes signs. And what you want to do for the AP test is relate how the heck you knew that f double prime changed signs. We want to relate that f double prime is the slope of f prime. So somewhere in this in your work needs to be how you recognize that f double prime changed signs, that f double prime was the slope of f prime. So if I had written this stuff up above, I wouldn't need to write that in there. But they like to know that you understand how you got f double prime there. Okay, so that's the answer to A. B says, can you find any relative max or mins of f of x? So again, they're asking about f of x, which is what we did in A. So what we would do to find max and mins of f of x is we'd take the derivative, and we'd set it equal to 0. Well, we've already done that for our sign line here, but we would have gotten x equals 0 and x equals 3. And so when we did our sign line, we found that there was a max at x equals 3, and our justification would be because f prime of x changes from positive to negative. So you'll notice these two questions, they're questions we've done for the last 6 months or so, and the justifications are the same that we've always done. It's just that we're pulling the information from a picture and not an equation. And usually it's actually easier to get the information from a picture if you understand the picture, versus having to do the algebra to get those same pieces of information. Alright, so C is probably the hardest part on here. But you had to understand A and B to be able to do this. So C says to find the x values of the absolute max and the absolute min from -2 to 4 of f of x. So note here, we're going to make sure we answer the questions. This time they want the x values of the absolute max and min for f of x, and they give us an interval. So we know a method. Anytime that we're asked to do absolute max and mins, we're going to make ourselves an X, Y chart. But we have to pay attention to what our Y is. And this time, we're finding the absolute max or min of f of x. So that's what our Y is. And so absolute max, absolute min, we're supposed to put the endpoints of our interval, for sure, and then, which is given, and then any time in between that f prime of x, that the derivative equals 0, any possible max or mins. So from what we did on B, we can see that we have a possible max or min at 0 or 3. Well, we already answered that 0 is not going to be a max or a min. So you can put it in there, but it's kind of going to be wasting your time because you know that it's not going to be a max or a min. So we can get away with just putting the 3 in there. Okay? And then we have to figure out, how do we get f of x? And so what we talked about above was how we get f of x is we're going to have to take the antiderivative of f prime of x. And we talked about, again, we're going to have to give that an interval. Okay? And so we can give, this one right here, we're not going to actually be able to find real values. On the second example, we're going to be able to find real values, and you'll see the differences. Okay? But you have to give it an interval. And so if you're looking at this little sign line that we made, and you just kind of think about where -2 and 4 are, -2 is over here and 4 is over here, the highest y value has to happen at x equals 3 because we go up from -2 all the way to 3 and then we come back down after 3 and that's it. We never have any other indication of changes. So 3 I know has to be the max. Has to be. Okay? And to justify that, we're not going to actually find that y value. We're going to justify it in the -2 and 4, but we're going to have a max at x equals 3, and it's going to feel a whole lot like the answer to B, from positive to negative, but we're going to add in something to make sure that we understand that it's the absolute. Okay? We're going to say changes from positive to negative only at x equals 3 from x equals -2 to x equals 4. So indicating that we knew that it went up all the way until 3, from -2 to 3, and it went down after 3, so from 3 to 4. So you can say this in a different way. You can say max at x equals 3 because f prime of x is greater than 0 from -2 to 3, and f prime of x is less than 0 from 3 to 4. And that says the exact same thing, that we're going up all the way until 3 and then down afterward. Okay, so that establishes that 3 has to be the absolute max. There's no other possibility here. But if you look back at this sign line here and you're following what f of x does, these little guidelines tell you that f of x goes up and then back down. The lowest point could be at -2 or could be at 4. We have to figure out which one is higher. Okay, and so this one's a little bit of a tough part. So I'm going to go back to that picture to show you. But if we wanted to compare, if we wanted to find f of x at either -2 or 4, we're going to have to use this integral. And so I'm going to have to give this integral an interval. So this is the hardest part to understand, but I'm going to do -2 and 4 here. Okay, and then I'm going to go up to the picture and talk about what that means. I'm going to go erase all of this stuff. So on this picture, if I set up the integral from -2 to 4 of f prime of x dx, what that means on this picture is the area from -2 all the way to 4. Okay, but because they didn't say area, it's just the antiderivative. Okay, it's going to count this part as a negative because that's below the x-axis and no one has flipped an interval and no one's put absolute values on it. That is currently a negative. So using the fundamental theorem of calculus, if you were going to work this problem by hand, you would get f of x. You would take the antiderivative first, and then you would do the bar -2 to 4, which would equal f of 4 minus f of -2. And the question for us to find absolute min is which one of these two guys is lower. We know one of those 2 points is the lowest value, we just don't know which one is lower. But we do know something about this integral. Because this is that purple shaded area, we know that purple shaded area as a whole is going to come out as a positive. Because there is simply more above the x-axis, all of this is going to count as a positive. Okay, and only this little bit is going to count as a negative. So more is positive than negative, so overall we're going to come out as a positive. So if I told you that f of 4 minus f of negative 2 is going to equal a positive number, that's going to tell you that f of 4 is bigger than f of negative 2. Okay, and so mathematically how you would write this is f of 4 minus f of negative 2 is greater than 0, which means positive. So if you solve this, you would get f of 4 is greater than f of negative 2 by adding f of negative 2 to both sides. That's the math that you would have to show to justify that you knew that the absolute min would happen at x equals negative 2, because f of 4 has to be bigger than f of negative 2. And all this area means is that, all this area being positive means is that you were going up all the way to 3. You were going up for all of this area, and then you just came back down just this little part. This is your down part, okay, and all of this is your up part that corresponded to this little line. So you went up a whole lot more than you came down, so negative 2 was lower. That's a really hard justification, and if you don't quite understand C right now, that's okay. Okay, that's something we're working on. If you can get A and B at this point, that's great. That's where we want to be. Okay, and then part D is a question they like to tack on now to see if you will follow rules, if you won't get thrown off and you'll keep working through. Okay, so D, we're going to use that piece of information up at the top that we haven't touched yet. So D gave you a new function, h of x, said it was equal to x squared times f of x. H of x is not pictured, f of x is not pictured. And they are just, it seems out of the blue. But it says find the tangent line equation for h of x at x equals 1. So there's two things that you always need for a tangent line. You need a point and you need a slope. So a point is simply an x and a y. So we have x equals 1. We need to know a y. And so since we're looking at h of x, that's our y, we need h of 1. Well, h of 1 would be 1 squared times f of 1. And well, 1 squared is pretty easy. You're going, what is f of 1? But if you look back in the original problem, and I snuck it in right here, the AP test would probably put it in a paragraph, and you may not use it until the very end, but you have to be aware that that's given to you. So f of 1 is 5. So when we go down here, we're going to have 1 times 5, which is 5. So we now have our point. Our point is x equals 1 and y equals 5. But we need our slope. And our slope of a tangent line is always the derivative. That's what the slope of a tangent line is. But we're taking the derivative of h of x. So when we take the derivative of h of x, you have to remember this right here is a product rule. It's got two things multiplied by each other. So we take the derivative of the first term, which is 2x, put it next to the second one, plus the derivative of the second term, which would be f prime of x, times the original first. And usually this statement is worth points. Just being able to do the product rule there and knowing you were supposed to do the product rule. But this is just the equation for the slope. We actually need the slope when x equals 1. So we're going to go plug in 1 to this thing. So we're going to get 2 times 1 times f of 1 plus f prime of 1 times 1 squared. Okay, and we've talked about that f of 1 is 5. And then f prime of 1, if we have these notes up above, f prime of x, we get from the picture. It's our y value. So f prime of 1 happens right here. Sorry, there's a bunch of mess. Okay, but f prime of 1 is right here, and that is equal to 1. Okay, so we're going to have 1 times the 1 squared, which is 1. So we end up with 10 plus 1, which is 11. And it asked us to write a tangent line equation, so you have to know that we're going to go y minus our y1, which was 5, equals slope, which is 11, times x minus 1. And there's our tangent line equation, which had very little to do with the picture. The only time you needed the picture was to pull that one value out. Everything else was given to you, or the product rule. So be aware of these, that they like to sneak those in. Okay, so we're going to move on to the second problem here. But just as a note as you go back through, these questions are difficult because people want to look at the picture and answer the questions. And you have to realize that the questions are generally not about what's pictured. These questions kept asking about f of x or even h of x, and none of those were pictured, and you have to use the clues that they're giving you to go back and figure out what is there. Okay, a lot of people's first response is to say the maximum has to be this, and that would be the maximum of f prime of x, but that's not what they're asking you about. They're asking about something that's not pictured. So these little sign lines are a great help to figure out what are the answers to the questions about something that's not pictured. It's trying to make a picture out of something so that you can answer it like that. Okay, so we're going to try another one, and this one has some geometric shapes. We're actually going to go find some areas and some slopes and things like that. Okay, so this one is the second way they like to ask these questions. This one, if you look at the y-axis, it's a graph of f of x. So f of x is pictured here. Okay, and then they give you some information that g of x is the integral from 0 to x of f of t dt. And they start asking about g. In both of the questions, they're asking about g. Well, g is not pictured, and so again, you have to figure out how are these things related to the actual picture. So with g of x being the integral from 0 to x of f of t dt, you have to ask yourself, well, how am I going to find anything about g? Well, since g is the antiderivative of f times dt, that must mean that g is going to be the area. But again, you have to have an interval for area, and this time you're given one. The interval must start at 0 and then ends at whatever value they ask you to plug in here. So whatever goes there also goes up top, and that will be your interval. So you must have an area interval. Okay, so then what if they asked you about g prime? Well, g prime, not necessarily on the picture here. You've got to be able to take the derivative of this formula to figure out what is g prime. So we've worked on this before. When you take the derivative of an integral, what you do is you take this, the variable part, and you plug it in. Okay, so we would do f of x, and then you multiply by the derivative of what's up here. So the derivative of x is just 1, so that's easy, but you need to remember that step because they have been crafty lately, and they will put a 2x up here, or something like that, or an x squared, and make sure that you take the derivative of it. So then g prime of x is just equal to f of x, but you have to relate that to the picture. Well, how are we going to figure this out? Well, this is just f of x, so f of x actually is the picture, and it's the y value on the picture, because f of x is on the y-axis. So then what if they asked us about g double prime? Okay, so g double prime is equal to the derivative of g prime, which is f prime of x. So you have to figure out, well, how does f prime relate to this picture? Well, f prime would be the derivative of this picture, and the derivative on a picture is your slope. So that's what we're doing with those three things. And so again, we can make our sign lines here and figure out what's going on. Okay, so if we were going to make our sign lines, one of them would be for g prime. Okay, and every time we make these lines, we take that and we set it equal to 0. So we talked about what g prime was. G prime is equal to f, which is the picture. So we're looking for where the y value is equal to 0. So looking at the picture, there are two places where the y value is equal to 0. So we would put 0 and 4 here. And then we would have 3 intervals to fill out. Left of 0, in between 0 and 4, and then right of 4. So left of 0, the y value is all negative. In between 0 and 4, the y values are all positive. And then don't make this mistake. Right of 4, we have no information. You can't assume that it goes negative. You don't know. So we can't answer anything about that. So we're not going to be able to answer 4 as a max or a min or anything. We don't know what happens after 4. All we know is that we're decreasing until 0 and then we're increasing after that. And this is really hard to get in your head, but if you can get it there, these questions become easy again. So this little sign line is supposed to give you a picture of what G looks like. G is not pictured. You're like, if you're looking at this graph, you're going, that looks nothing like it. And no, it doesn't. G is not pictured, but whatever G of X is is decreasing than increasing. Okay, and should have this minimum sitting at 0. That's what should happen there. All right, and so then we are going to make our second derivative line, our g double prime, and this one's going to be a little weird, okay, because of this picture. So what we would do to make our second derivative line every time, no matter what we have, is we take the second derivative and we set it equal to 0. Well, how the second derivative relates to this picture, it's the slope of f prime. So we look where the slope is equal to 0. And the thing that we didn't talk about in the last problem that's important is the slope can be 0. You can set these things equal to 0 or undefined. So this one is strange because if you look at this picture, the slope is undefined here and here at 1 and 3, and it's 0 all the way through from 1 to 3. So we have a whole section, and the AP test probably wouldn't ask you about any inflection points here because we have this whole section. But 1 to 3 is all kind of blocked out. We have an issue there. But we can tell the slopes to the left and the right. We just don't know what's going on between 1 and 3. Okay, so to the left of 1, the slopes are positive. To the right of 3, the slopes are negative. Okay, and then we have something going on in between 1 and 3, but that whole section is just not good, okay, for us. So now we're going to go answer these questions, see what they actually asked us. So the first thing says, find g of -2 and g prime of -2. All right, well, we're going to do one of those at a time. So if we're going to find g of -2, that's our first function right here, and all we're going to do is plug it in. So we're going to go 0 to -2 of f of t dt. And we talked about up above, that means that's the area of this picture, okay, and we're going to have to give an answer. Now, something weird about the way this interval is written, this interval 0 to -2 is going backwards. That interval was flipped, which means that whatever it looks like on the picture, we have flipped the sign of it. So if you look, -2 to 0 is talking about this area right in here. And that is negative. But the way that the interval is written has been flipped, so it's going to change the sign of whatever that was. So we're going to actually write this as a positive. But we have to find that answer, and it actually wants a real answer here, and we're able to find that because that's a triangle that has a base of 2 and a height of 4. And so the ending area is going to be 4. So we're going to do 1/2 base times height. Okay, and it's positive because this interval was flipped, and we didn't get the option. We had to start at 0 because that's how g was defined. Okay, so that's all we're doing there. And then when we answer g prime of -2, from what we've said earlier, g prime is equal to f. So we would go f of -2. Well, we've said f is simply the picture, so we're going to look at the y value at -2. Well, at -2, our y value, our f, happens to be -4. And we're done. That's the points that they asked for. So on this, even if you struggled with one of them, if they ask you to do multiple things, there's going to be points for each thing they ask you to do. So don't leave it blank if you can't answer g. Okay, answer the g prime. That's all you can answer. Or if you can't answer g prime, but you can answer g, do that and then move on. Okay, so part B asks us to do something very similar. It just asks us to do 3 things. Okay, so it says g of 2. That's what we're going to do first. So we're going to plug it into our g of x. And we're going to go from 0 to 2 of f of t dt. So we talked about that's the area, and that gives us the interval 0 to 2. So we got to go to the picture and figure out what it's talking about. So the area from 0 to 2 is talking about this little trapezoid. And if you'll notice, this time, because we started at 0 and ended at 2, that's written in the correct order. We had to start at 0 because that was what they told us. Okay, but that's written in the correct order, so whatever it looks like, we're going to leave it. Well, it looks like a positive, we're going to leave it as positive. So if you don't remember and you panic, you don't have to do a trapezoid formula. You could do a rectangle and a triangle. But we're going to go do a trapezoid formula just so you remember. So one of the bases is 2 and the other base is 1. And then the height is the difference between those, and the height here is 2. So for our trapezoid, we're going to do 1/2 because that's part of the formula. And then the height, and then the sum of the bases. So we end up getting 3. That area right there is 3. You get it from a rectangle and a triangle, that's fine. Okay, and so then we're going to do g prime of 2, which is f of 2. which we're looking at the y value again, the y value in our picture. So f of 2, the y value here is 2. So we're going to write down a 2. And then last one, g double prime of 2 is equal to f prime of 2 from up here, which was our slope. So we want to know the slope at 2. And we kind of talked about this earlier, but the slope at that point is 0. Okay, so we're going to write down our slope as 0. If they had asked us the slope at 1, we would have said undefined or does not exist. If they said the slope at 3, we would have said undefined or does not exist. The one that I didn't ask you on this one, but that gets asked a lot, what if I asked the slope at 0? And so if they ask that, that's okay. This is a straight line. You can do rise over run and find the slope of that. Anywhere along this line has the same slope. Okay, because it's a straight line. So it's a rise 2, run 1, that slope is 2. All the way along here. Okay, the slope is 2. And then you could do the same thing over here. All the way along this section, the slope would be negative 2. And then we talked about in between here, that's our 0. When we have these undefined points at the end. Okay, so they can ask you about slopes that have constant slopes, so that your straight lines, they can ask you about those. Why we didn't do that in the previous problem was those were curvy and they didn't have a specific slope. Okay, so that's it for graphs of the derivative. It's a relatively difficult section, which is why this video went on forever. But as the award for finishing this video, I have you a Happy Easter picture. This is a cat on camera, and she will be reappearing in future videos.